You're out at night trying to take a photograph. Because there isn't much ambient light available, your camera's software does the only thing it can. It keeps the shutter open longer to gather as many photons as possible. The problem is the human body holding the phone. Even if you think you're standing perfectly still, your muscles involuntarily twitch, your lungs expand and contract, and your heart physically pumps blood. This diagram shows exactly what happens inside a camera. A single point of incoming light hits the sensor panel, but because the camera body drifts laterally while the shutter is open, that tiny point smears into a wide streak across the digital canvas. A crisp photograph requires light to strike exactly the same pixel for the entire duration of the shot. The longer the shutter remains open, the wider that streak becomes, and the worse the final image looks. Without some way to intervene, the physics of low light and the biology of human hands make mobile photography highly impractical. We expect software to fix our digital problems. You might assume your phone's Electronic Image Stabilization, or EIS, would just calculate the error and sharpen the image after the fact. But software can only manipulate data that already exists. It can crop a frame or track a moving object, but no algorithm can force a physical sensor to collect more light. To stop a physical motion, engineers had to build a kinetic intervention inside the device. They developed Optical Image Stabilization, or OIS. The objective of OIS is straightforward but difficult to execute. Suspend the internal camera components and hold them perfectly still, even as the outer casing of the phone shakes around them. Code wasn't going to cut it. To solve a physics problem, the smartphone had to house a precision-engineered mechanical machine. The stabilization process operates as a continuous physical feedback loop, and the brain of that loop is a microscopic sensor called a MEMS gyroscope. MEMS stands for Micro-Electro-Mechanical Systems. These chips are manufactured with the same techniques used for computer processors, producing entire mechanical structures smaller than a single grain of rice. This schematic shows a central mass suspended by springs, continuously vibrating. When your phone tilts, the system rotates. The Coriolis effect pushes the mass laterally against its springs. This shift changes the electrical capacitance between contact plates, instantly generating exact pitch and yaw coordinates. Through this mechanism, the unpredictable shaking of your hands is instantly quantified into exact mathematical data. Those exact coordinates are immediately fired from the gyroscope brain over to the system's muscle, tiny electromagnetic actuators. These actuators operate using a simple physics principle. Running an electric current to tightly wound miniature coils generates a controlled magnetic field. In this animated cross-section, we see compensation. If the phone casing tilts downward, coils generate a magnetic field pushing the central lens upward by the exact amount. Because the lens moves oppositely, incoming light remains perfectly locked on to the image sensor below. This complete cycle, detecting the movement, calculating the math, magnetizing the coils, and shifting the lens, happens thousands of times every second. OIS operates as a relentless, microscopic tug-of-war, actively neutralizing your hand movements before blur even has a chance to form on the sensor. Pulling back out of the lens to the human scale, we see the real-world execution. You are a person standing on a dark city street, holding your phone up to capture a moment. Because that internal sensor is mechanically stabilized against your natural tremors, your camera software has the freedom to safely leave the shutter open much longer. The physical hardware buys the sensor more time to soak up photons. This yields brighter low-light photos, reduced digital noise, and buttery smooth video while walking. As the camera bumps on the back of our phones continue to expand, engineers are building in room for multi-axis movement, creating hybrid systems that combine physical OIS with electronic stabilization and artificial intelligence to predict exactly how you'll move next. Every sharp handheld photograph is the result of thousands of physical adjustments, all occurring within the few milliseconds the shutter is open. This high-speed coordination of magnetism and motion is built specifically to hold your memories and focus.